show that the linear system has infinitely many solutions. So x plus 3y equals negative 3, and 3x plus 9y equals negative 9. So graph the linear system. So again, we're going to solve for y. So x plus 3y equals negative 3. I'm going to subtract my x. So I get 3y equals negative x minus 3. Then I have to divide by 3. So I get y equals negative 1/3 x minus 3 over 3, which is 1. So I'm going to start at negative 1, and I'm going to go down 1, right 3. Down 1, right 3, or up 1, left 3 is the same thing. So here is my first line. Okay, now I'm going to solve the second one for y. So 3x plus 9y equals negative 9. I'm going to subtract my 3x. So I get 9y equals negative 3x minus 9. Then I have to divide by 9. So I get negative 3 over 9x minus 9 over 9 is 1. 3/9 simplifies to 1/3, keep my negative, minus 1. So again, I start at negative 1, and I go down 1, right 3. Down 1, right 3. So this is also line 2. So the equations represent the same line. So any point on the line is a solution. So the linear system has infinitely many solutions. Okay? Because this is a solution, this is a solution, this is a solution, this is a solution. We can just pick tinier and tinier spaces to move, and we'll still get a solution. Okay? Substitution. If we solve the first equation for x, we get negative 3y minus 3. So then we are going to plug that in for x here. So negative 3y minus 3. So substitute negative 3y minus 3 for x. And then we distribute. So 3 times negative 3y is negative 9y. 3 times negative 3 is negative 9. So negative 9y plus 9y cancels, and we get negative 9 equals negative 9. The variables are eliminated again, and you are left with a statement that is true regardless of the values of x and y. This tells you that the solution has infinitely many solutions. So if you get something that's false, like 0 equals 4, you have no solution. If you get something that's negative 9 equals negative 9, so it's always true, then it's infinitely many solutions. Okay. So now you're going to have some checkpoints. So go ahead and pause the video and do those. Okay, so our last bit of notes here. The number of solutions of a linear system. So we're looking for the number of times the lines intersect. So here we have one solution, and it is this point right here, whatever that is. So the lines intersect because the lines have different slopes. Okay? Here we don't have any intersections, so the lines are parallel, and the lines have the same slope and different y-intercepts, because that's what makes them parallel. Okay, and here the lines are the same, so fancy word for that is coincide. Okay, they are the same line, They have the same slope and the same y-intercept. So this is a solution, this is a solution, this is a solution. Any place we point on this line is a solution. Here we have no solutions, and here we just have one. So those are different types of linear systems.